Welcome to the Chapter 8 Part 1 video where we're looking at conic sections. This is section 1, but we already reviewed in class or learned in class about what a conic section is and the different types that we'll be looking at. So in this video, we're going to be focusing on parabolas, and we're going to be focusing on this from a geometric point of view as opposed to how we normally have been thinking of parabolas from an algebraic point of view. The reason we're so interested in conic sections is because they are the paths of nature. Free moving objects in a gravitational field follow the path of a conic section. What does that mean? If I drop something from the roof of a building, or if I look at a meteor in orbit around, the sun, or that enters into the sun's gravitational pull, if I look at the moon around the earth, if I look at the earth around the sun, those are all pathways that follow conic section projections. Okay, so either the path itself forms a conic section, or as we've seen from things falling off of a roof or dropped from a height, it's actually their position that follows a parabolic projection. Okay, so from a geometric point of view, what is a parabola? A parabola is all of the points that have the same distance from a given point and a given line. Okay, so the point is called the focus, and the line is called the directrix, and all of the points on the parabola are the same distance from those two objects. If I look from the focus to a point on the parabola, it's the same distance as the point of the parabola perpendicular to the directrix. The distance between a point and a line is always measured perpendicularly. I can do this for any point. If I pick this point on the parabola, I can find the distance from the focus will be the same distance to the directrix. Okay, every point on the parabola has that property. Some important lengths or distances to know here. We have the distance from the focus to the vertex is called P, and the distance from the focus perpendicular to that vertex is the absolute value of 4P. And we'll go into more specifics on that, but it's called the focal length and the focal width. So P is called the focal length. That's going to be very important for finding our equations given these geometric properties. So let's look at some of the properties, and we are going to focus only on parabolas with a vertex at 0, 0. So that means I've got 4 options. It's going to open up, it's going to open to the right, it's going to open down, or it's going to open to the left. Okay, 4 possible parabolas that we're looking at, and then transformations of those. The standard equation, when we have our x squared, we've seen this is our function, so that's going to be opening upwards and downwards, and that gives us a positive p or a negative p. When y is squared, it's going to be opening sideways, so it'll open to the right or to the left. To the right is when we have a positive p, and to the left is when we have a negative p. Okay, so based on the equation, we can see which direction our parabola will be opening. The vertex, sorry, the vertex will always be halfway between the focus and the directrix. So the vertex that we're used to looking at for a parabola is halfway between the focus and directrix. So we need to know where the focus and the directrix are. Well, the focus will be 0, p. Now p could be positive or negative, and the directrix will be the line y equals negative p. All you do is replace x and y, switch x and y values, and then you have a sideways opening parabola. Okay, so that's what these different columns mean. This is our up and down facing parabola in the first column, sideways facing parabola in the second column. Focal length is always p. Focal width is always 4p, but we're going to take the absolute value of it. It's always going to be a positive width. Okay, so the length could be negative. If the length is negative, that means that the parabola is opening downward or to the left, depending on which variable we're looking at, which variable is squared. Okay, so we're not changing our definition of parabolas. We're just looking at them from a new perspective. Let's look at some graphs. If we have our x squared That means it's going to be opening upward and downward. Our focus is 0, p. So our focal length here is p. Then we have our focal width across is 4p, or absolute value of 4p. Since p is positive, it will just be 4p. And that means from the focus all the way across to the parabola, perpendicular to the line between the focus and the vertex. The vertex, I already mentioned, lies halfway between the directrix, which is a line, and the focus, which is a point. In our second example or graph here, we have a parabola opening downward. That means that this distance here is p, but now p will be negative. Our distance across our focal width is, again, 4p, but this time we have to do absolute values because p is negative. And then our directrix is the line y equals negative p. If we switch and we do horizontal parabolas, all that's changing is the role of x and y. So our vertex is still halfway between the focus and directrix. The distance from vertex to focus is still p. The distance from focus to the parabola is still 4p. And the directrix is still the line x equals negative p. Okay, same thing for if it's opening to the left. The distance between the focus and the vertex is p. The distance from the focus across perpendicular to the vertex is 4p in absolute value bars. The vertex is halfway between the focus and the directrix. Focus is a point, the directrix is a line, and the equation of the directrix is x equals negative p. In this case, if it's opening to the left, p will be negative, so our value x equals will be positive. Okay. Let's look at if we can find the equation of a parabola from in standard form from the given directrix and focus. Okay, so first we need to remember what is the equation of a parabola. Okay, so when we're looking at our parabola, it's either going to be x squared equals 4py or y squared equals 4px. How do we know which one to use? Well, we need to see, is our parabola opening upward and downward or left and right? If the directrix is the line x equals 3, so I would go 1, 2, 3. There's my directrix. Directrix, I should have done it dashed, so let me fix that because it's not part of the parabola. Kind of like an asymptote is not part of the graph, it's just to help us visualize it. And then the point negative 3, 0, and I'm going to do it as an open circle because this is the focus, but it is not on the parabola. That's not part of my graph. Okay, so I can see here the parabola is going to have a vertex halfway between those, which is 0, 0. Moving, it opens away from the directrix. It will never cross the directrix. So that means that this is opening sideways, which means we're going to use the y squared formula. To find my value of p, I want to find the distance between my focus and my vertex, or you can think about it as half of the distance between the focus and directrix. So the distance here, p equals 3. Again, I can find that just from the graph. I don't have to do the calculations to find that if I'm doing my sketch. So if p is negative 3 because it's opening to the left, and then I can say y equals 4 times negative 3x, y equals negative 12x. There is the equation of our parabola. Okay, so using all of those properties that we just learned in order to apply them to find the algebraic expression of the parabola. Okay, next what we want to look at is what if our vertex isn't 0, 0? And this is the one that you want to have easily accessible in your notes. This is a table. I would suggest having a place where you can have all 4 tables for our 4 different conic sections in one place. And really circles and ellipses go together. So that's why this chapter is only 3 sections long. So when we have a vertex HK, all we're doing is we subtract the H from the X and the K from the Y, and that's the only thing about the equation that changes. Okay, if the X part is squared, it's still opening upward and downward. If the Y part is squared, it's still opening left or right. Now the focus is still 0, comma P, but now we have to add H and K to that. So it's H, comma K plus P. Okay, it's still a distance P away from the vertex. If our parabola is opening sideways, the P gets added to the X value instead. The directrix is going to be K minus P, just like the focus was K plus P. The directrix is K minus P because those are the same distance away from the vertex. Same thing if it goes sideways. The axis or axis of symmetry is still going to be X equals H, Y equals K. That's the same as we saw in algebra. Focal length has not changed, it's P, and the focal width has not changed, it's the absolute value of 4P. So what has changed, all we've done is we've added a component of H and K to each of our formulas. So let's look at what that would look like computationally. We want to find the equation of a parabola in standard form if we're given now not the focus and directrix, but the vertex and the focus. So again, I'm going to start out by drawing a picture. Now we have the vertex at 1, 2, and the focus at 1, -2. Now the graph of a parabola goes from the vertex around the focus. I can say, since this distance is 1, 2, 3, 4 units, I know the directrix is 4 units, the opposite direction. So there is my directrix. That means my parabola looks something like this. That's opening downwards, so this is going to be an x squared equation, but I have h equals 1 and k equals 2. So that means I have x minus h squared equals 4p times y minus k squared. Sorry, the y is not squared. Substituting here, I have x minus 1 squared equals 4. Our p value here goes down 4, so p equals -4 times y minus k is 2. So this is x minus 1 squared equals -16 times y minus 2. And we're going to leave it like that so that we can see all of the components of our parabola. Okay, so again, just finding h, k, and p in order to solve this parabola. Drawing a picture is very important. You should have a picture for every single one of these that you're calculating. Okay, we'll do more practice in class. If you have any questions, please feel free to email me.